Hello, my name is Maddox, and this is my Physics Lab 4 about oscillations. A little introduction. In this lab, we tracked an oscillating mass on the end of a spring and compared it to a computational model consisting of the same physical constants as the original model. And as a summary, this lab showed that oscillating movement is predictable. Some models and equations that we used in this experiment. We initially had to use the initial position and velocity vectors, as well as the equations for spring potential energy, gravitational potential energy, kinetic energy, and then total energy. And then within the while loop, we also had to use the position update and velocity formulas so that the values of the energy would modulate. Our video explanation, we used a pre-made video of an oscillating mass spring system, and we assumed that the system was the mass spring in Earth, and therefore that there are no forces or energy components in the surroundings. And using Tractor, I obtained my initial position, which is shown right here, and assumed the initial velocity to be 0 meters per second. Here's my computational model, or the most important parts of it. In the top left, we set the mass equal to the same mass as the physical model, as well as the starting position and velocity. And then also the gravitational constant and the spring constant and the relaxed length of the spring. And then this on the right was the code that was within the while loop that updated each energy component. And then here are the results. On the left is the picture of the spring going around. And then the graph, it shows the change in energy versus time. As you can see, delta U spring and delta U grav modulate inversely, and delta E stays constant, meaning that energy is conserved within the system. Some similarities and differences. Some similarities was that both models included spring potential energy, gravitational potential energy, and kinetic energy, and both models had the same physical constants. Some differences is that the computational model did not include a drag force. However, this likely didn't cause much difference between the two models. The only source of error that I could find was that there possibly being some non-zero initial velocity when tracking the mass in the video. But since the time was set to 0 at the initial position, it doesn't really matter. What does it mean? So for number one, the energy principle is satisfied, as you can see by the orange line, which represents the change in energy. It remains constant, which means that energy is conserved. Then two, to find the oscillations of, or the two oscillations using the X and Y data, I took the period of oscillation by taking the time between 3 oscillations and dividing it by 3. And the two estimates are fairly similar. As you can see, the X oscillation time was 1.646 seconds, and the Y was 1.519 seconds. And these data discrepancies are likely the cause of the difference. Thank you.